Yeah.
Maybe your internet lagging kali.
Okay.
Anybody else? Ada yang problem dia nampak screen?
Nampak sudah, Sir?
Okay. So for today's topic is about a single phase induction motor. So let us read first the introduction. The motors that are operated by a single phase supply are known as single phase motor. So supply-nya is single phase. Previously yang kamu belajar is three phase induction motor. So the supply is three phase supply. So these motors are smaller and mostly these are made in the fractional horsepower range. The single-phase motor are extensively used in the home appliances, offices, shops, as well as industries. For example, motor ni kena pakai in operating washing machine, fridge, air condition, blender, coffee maker, record player, etc. So basically only a domestic application lah. So di sini ya ada explain on what is the working principle of the induction motor, a single phase induction motor. So I will explain sikit saja later just to highlight because you have already seen the video more clear on how the single phase induction motor works. So basically the single phase induction motor ya ada two main part which is a stator and a rotor. So sama macam three-phase induction motor, there is no electrical connection between stator and the rotor. So basically, it will transfer the EMF from the stator to the rotor, macam transformer from primary side to the secondary side. So just now it mentioned that single-phase induction motor will give the double revolving field theory. So this double revolving field theory will make the single-phase induction motor in the running because each of them is forcing into the direction. So basically, macam if you have the rotor here, it produce two magnetic field. Sini sama sini. So this one is north south. This one is macam ni. This one is going, let's say it is going here. This one is going here. So it has two revolving magnetic field. This rotor will not turn because each of them is trying to pull kemari and satu kemari. So this will make the rotor cannot turn. So as a solution tadi just now, they put the auxiliary winding inside the stator. So this will cancel one of the field, but some of them will be added up into this yang original di sini bercampur. So ia punya amplitude makin besar. So this will make one force much higher compared to yang kemari. So this one will be less ia punya force, but di sini ia punya force is much higher. So this will make the rotor turn into unidirectional lah, bukannya ke sebelah. Okay. So we know that the single phase induction motor, it has two direction. It can go forward and backward because of the magnetic field. So let the rotor runs at a speed of NL. So we know that the speed of the motor is represented by NL, RPM, and the synchronous speed is represented by NS. So the slip of the motor is respect to the forward field. So normally the SF is equivalent to dengan S. We know that S is equal to NS minus NL divided by NS. So since we have two field, we have forward field and backward field. So the backward field, ia punya slip is equal to SB equal to NS minus bracket minus NL over NS. But from this book, the equation jadi plus. So this plus, the author from this book, ia mau the equation become plus. So he forces this equation jadi macam mana. So basically 2NS minus NS minus NL divided by NS. Kenapa ia mau buat macam mana? Why he make it like this? Because he wants to make the equation become like this. Because this one is equal to S. So if you try to rearrange back this equation, let's say macam ni, 2NS, you open this bracket, minus NS, minus minus become plus NL divided by NS. So it is the same. So 2 minus NS become NS plus NL divided by NS. So it is back to SB. But he just forces this equation become like this. So he can create NS here. So the final equation for backward field for slip is equal to SB equal to 2 minus S. So the rotor equivalent circuit due to forward and backward field are shown in the figure 11.4. So this is the forward field and this is the backward field. The difference between them is R2 divided by S for forward, but the backward is R2 divided by 2 minus S. So let us look here in example 11.1. So the speed of a 220 volt 50 hertz 4-pole single phase induction motor is 1450 RPM. Now you need to calculate the slip for the forward field and the slip due to backward field, and calculate the effective rotor resistance in each branch if the rotor resistance standstill is equal to 10 ohms. So the first one is much easy because you just need to calculate the slip due to forward field. We know that the slip due to forward field di sini SF is equal to S. So first, in order to calculate SF, you need to know what is NS. So NS is equal to 120 F divided by P, you get 1,500. So SF is equal to NS minus NL divided by NS, you get 0.03. So slip due to backward field is equal to 2 minus S. So 2 minus 0.03, S is equal to yang kamu dapat di sini tadi. So you get 1.97. So you need to calculate for question number 3 is the effective rotor resistance due to forward field and backward field. So RF is equal to R2 divided by S. So we know this R2 is given here. This is the rotor resistance at standstill. So R2 divided by 0.03, you get 333.3 ohm for the forward field. And then for the backward field, you get 5.08 ohms. Now, can you try the drill exercise 11.1? The slip of a 120 volt 50 hertz 4-pole single phase induction motor is 4%. So ia ada mention di sini, the slip is equal to 4%. Now you need to calculate slip due to forward field, and then slip due to backward field, and then calculate the effective rotor resistance in each branch if the rotor resistance standstill is equal to 6 ohm. So this is kamu punya R2. So can you calculate what is the slip due to forward field and slip due to backward field and slip due to and the effective rotor resistance when the rotor stands still is equal to 6 ohm. Number 1, ada yang tahu sudah jawapannya berapa? Question number 1.
1500.
Huh? No, the slip due to forward field.
Okay.
Berapa? The slip due to forward field berapa? Anda payah kira pun boleh ada jawapannya sudah.
0.04.
Yeah, correct. So di sini ada mention the slip is 4%. So we know that the slip of forward field is equivalent to dengan S. So the slip of forward field is equal to 0.04. Now, ini apa jawapannya? So SB is equal to 2 minus S.
$1.96.
Equal to 1.96. Sorry. So the effective of for rotor resistance for each branch, RF is equal to RB is equal to
$150.
RF,
RF, yes.
RB,
$3.06.
3.06 ohms. So yang lain dapat the jawapan MS macam yang lain. How about the others?
Yes, SM.
Okay, very good. So it's quite straightforward. You just need to apply you punya formula. So now let's move on to the equivalent circuit. So the equivalent circuit of a single-phase induction motor consists of series connection between the forward field circuit and the backward field circuit. Each circuit is similar to the polyphase induction motor. In the backward rotating field circuit, the parameter S is replaced by 2 minus S. Since the forward and the backward revolving field have the amplitudes that are 1/2 of the alternating field, therefore it is necessary to apply 0.5 factor, a factor of 0.5 to get the required related parameters. So as mentioned just now, you have two, yang originalnya tadi di sini, you have two magnetic field kan? Here, and S here, and lagi satu sini, SM. So you have two magnetic field. Satu will be representing forward, satu will be representing backward. So due to this, if you combine, it will become, if you combine these two, it will become one amplitude of magnetic field of field lah. Since ia ada dua, so you need to divide this one total amplitude jadi 2. So satu untuk forward, satu untuk backward. So that's why yang di sini tadi amplitude-nya is divided by half. So that's why it is affected in kamu punya equivalent circuit. Ya di sini, if you look at this equation, ya ada 0.5. Karena masukkan factor 0.5. Because of the, since the forward and the backward revolving field have the amplitudes that are 1/2 of the total alternating field. So, di sini ia ada formula in order to get ZF and ZB. It is up to you if you want to memorize the formula, or you can just simply understand the formula for to understand the concept of parallel resistance circuit. So, for example, di sini, if you have R2 and R1, so total resistance here is R1 kali R2 divided by R1 plus R2. Is it correct? If you want to calculate ia punya total resistance. Correct? Okay. So, if you look at this diagram, so let's just focus on this part first for the forward. Okay, sorry. Copy. Okay. So if you look at this part, what is dia punya ZF? ZF is equal to JXM kali dengan berapa? JXM kali dengan R2 over S campur JX2. You need to know yang if you have inductor di sini or reactance, you need to include J. So divided by JXM plus R2 over S plus JX2. But you need to remember tadi just now, they have the amplitude of the magnetic field. The amplitude of the field is divided by 2. So you need to multiply dengan 0.5. So you can compare the equation yang di sini tadi just now. You can compare here. So it is the same dengan equation yang ini. Okay, let's try again yang for this one. So if you look here, total resistance for the total impedance for ZB is equal to JXM kali dengan R2 divided by 2 minus S plus JX2 divided by JXM plus JX2 plus R2 divided by 2 minus S kali dengan 0.5. So is this part clear for the total resistance for the parallel part? It is up to you if you want to remember the formula. But for me, it is much easier if you just understand the circuit diagram. Okay. So since di sini for ia ada dua kan rater. So this one is ia punya stator part, and this part is ia punya rotor part. We know that if you're represented by R2, if you're represented by R2, it is representing you punya rotor side. And if it is denoted by 1, we are looking into your punya stator side. So they make this into equivalent circuit. So the total impedance for the circuit is ZT is equal to Z1 plus ZF plus ZB. So this one biasalah R1 plus J X1. So the total value for current yang di sini I1 is equal to V1 divided by ZT. So the stator copper loss here representing stator. So if you want to find the stator copper loss is I1 square R1. Now if you want to find I2F, you need to apply current divider rule. So if you want to find I2F di mananya. So if you look at this diagram, I2F is going to here. So how do you apply current divider rule? So I2F is equal to JXM divided by R2 divided by S plus JX2 plus JXM kali dengan I1, the total current from here. So current yang masuk sini is I1. So you need to remember all these fundamental equation in order to solve this problem. But sometimes I know some of you cannot remember on how to apply the current divider rule. You can memorize this formula. You will get the same result also. So similarly to calculate I2B is going here. So you just need to apply current divider rule, which is I2B is equal to JXM divided by R2 divided by 2 minus S plus JX2 plus JXM kali dengan total current yang masuk sini, which is I1. So di sini, what is the A gap power due to forward field and the backward field? So PAGF is equal to I1 square RF, and then PAGB is equal to I1 square RB. So kenapa we are using RF saja, and we are not including dia punya, tadi just now we have RF sama XF and RB and JXB, but we do not include this to calculate dia punya A gap power. We do not include because we want to calculate dia punya real power, true power. True power will only exist in resistor. The power yang ada di sini is only reactive power at reactance sama capacitance. But in this question, in this equation, ia mau ia punya true power saja, the A gap power. So that's why you are using only resistor. So in a polyphase induction motor, the expression of power developed is already derived. So PD is equal to PAG bracket 1 minus S. So therefore, the power developed in the single phase induction motor is PD equal to 1 I square REZF 1 minus S plus I1 square REZB 1 minus 2 minus S. So this equation representing forward resistance, and this one is for backward impedance. So if you rearrange this one, the equation, it will become, just now you punya di sini plus kan, here plus. So if you rearrange this equation, it will become minus di sini. So in the end, the power developed is equal to PAGF minus PAGB bracket 1 minus S. This is for the single phase induction motor, but this one is for 3-phase induction motor. So the torque due to forward field is PAGF divided by omega S. And then torque due to backward field is equal to PAGB divided by omega S. And then the torque developed will be TF minus TB. So di sini, if you look at this one, if TF is equal to TB, what happened to the rotor?
Stay.
Stay. So the rotor will not rotate because the torque for the forward field is equivalent to the backward field, you punya backward torque. So that's why they apply the auxiliary winding in order to get forward torque is much higher than the backward torque. So in this diagram, it will represent the forward torque is much higher than the backward torque. That's why the rotor will spin in the forward directional punya torque rather than the backward punya torque. So in alternative way, the expression of torque can be expressed equal to PD equal to 9.55 divided by PD divided by MS. So di sini ada explain when the ZF is much higher than the ZB, consequently the voltage due to forward field is much higher than the backward field, so EF is greater than EB. Therefore, as the speed increases, the resultant forward A gap field increases while the resultant backward A gap field decreases. So as the speed makin naik, the backward torque, the backward dia punya ni makin turun, tapi dia punya forward field increases. So let's look at an example di sini. Let's buat dia punya new page. Okay. Example. Sorry. Okay. So in order to make this question easy, you can draw you punya equivalent circuit. Okay, so this is the equivalent circuit for single phase induction motor. So ia beritahu di sini, the equivalent parameters of a 220 single phase induction motor are R1 equal to 6 ohm and R2 is equal to 6 ohm. So di sini is R1, X1, XM, XM, R2, divided by S x2 R2 divided by 2 minus S x2. So R1 is equal to 6 ohm. R2 is also equal to 6 ohm. X2 is equal to 10 ohms. X1 and X2 is equal to 10 ohms. And then Xm is equal to 150 ohms. Now you need to calculate what is the input current, which is this one, I1. And you need to calculate what is the input power and the power developed. So the input power, you have to PAGF and PAGE. And you need to also calculate what is the torque developed. Consider the slip is 3%. So S is equal to 0.03. And the motor speed is equal to 1,500 RPM. So NL is equal to this one. So in order to calculate the input current, I1 is equal to V1 divided by ZT. So you need to calculate what is ZT first. So ZT is equal to Z1 plus ZF plus ZB. So what is ZF here? ZF is equal to JXM R2 divided by S plus JX2 divided by JXM R2 divided by S plus JX2 kali dengan 0.5. So what do you get for ZF here? And then ZP is equal to JXM berapa ZF-nya? How much is the ZF? Bertahya kamu kira. Coba sebutkan di berapa. Saya dapat lihat dia punya recet.
Aku salah buat. Tapi final answer is ZF is 34.3 plus
0.3 plus J
47.6J.
7.6J. This is for ZF.
47.6.
Okay. For ZB,
Huh? Oh,
ZB?
ZB haven't.
1.34
berapa?
1.34
1.34
plus J 4.71
okay.
71.
71. So what about the others? Do you have the same answer?
Yes, sir.
Sama? Good. So what is the punya ZT? ZT is equal to 6 plus J10 plus 34.3 plus J47.6 plus 1.34 plus J 4.71. So ZT is equal to
41.64
41.64
plus 62 plus J 62.31.
Okay, so I1 is equal to V divided by ZT. So what do you get? 220 divided by 41.64 plus J 62.31.
One 1.63
1.63
minus J 2.44.
ampere. So in the question, kamu sudah dapat you punya input current for the first question. This is the first question. Now the second question, suruhnya kamu cari input power. So cari PAGF and PAGB. So PAGF is equal to I1 square RF. PAGB is equal to I1 square RB. So based on this equation, what is you punya RF from ZF? What is you punya RF? Berapa RF-nya?
6.
Hah? RF. From this ZF, berapa what is you punya RF? The forward resistance.
R2 over S.
No.
34.3.
34.3. So this is kamu punya RF and this is kamu punya RB. So RF is equal to 34.3. So you need to find you punya magnitude from this. Ini berapa magnitude-nya? Change this one to magnitude. Berapa magnitude-nya this one?
Uh, 2.93.
2.93.
Angle negative.
Negative.
56.3.
56.3.
3.
Okay. Okay, so 2.93 angle minus 56.3 square kali dengan RF, which is 34.3. Dan di sini 2.93 and then for number 3 you need to calculate you punya power developed. So the power developed is equal to what is just now? Power developed is equal to this equation. And then last kali you suruh cari torque. Is it? Yeah, torque developed. Torque developed. So D equal to 9.55 So berapa PAGF-nya?
I got negative 113.2 minus J 271.9. 271.9.
271.9.
Yeah.
Sorry. What? For PAGB,
Negative 4.42. Minus J 10.6.
okay. So, but in reality, power, we only look at you punya magnitude. So, if you want to know the you punya real power, you can convert this one first to you punya magnitude, the polar one. Actually, you do not need to include you punya angle tadi just now. But it's okay. So magnitude-nya berapa?
294.5.
This one, yang backward.
Yang backward. $11.5.
Okay, so PD is equal to 294.5 minus 11.5, 1 minus 0.03.
$274.51. Bukan 1 minus 0.03 kah for the NS?
Mana? NS?
Yeah,
And-
because if 0.303 move to the right side is NS minus 0.03 NS.
Yeah, minus 3. 1 minus 0.03, berapa tu?
0.97. And S is equal to 1546.4.
1, 5. 1,
46. 1546.4.
1546.
Ada times 9.55.
Berapa?
Yang ada tinggal tu set. Yang TD.
TD berapa?
274.51 times 9.55 tadi.
274. Point
Bukan set.
Setinggal 6.55 yang di depan punya.
Okay. Oh ya.
So 1.7.
1.7. Apa unitnya?
Newton meter.
Okay. So di sini kamu ada drill exercise 11.2. So you can try this sendiri, and maybe we can discuss this on Wednesday if kamu udah clear for the drill exercise. So the question is quite similar. So the beza is only, the slip is 4%, R2 and R1 is given, X1 and X2 is given, Xn is also given. Okay, so just to recap back on what we have learned today. So we are learning about single phase induction motor. So you punya konsep sama macam three phase induction motor. Ya ada rotor and stator, and there is no electrical connection between stator and rotor. So we need to transfer the field from the stator to the rotor, macam transformer. But the stator will produce two field yang membuatkan namanya double revolving field. So this will make the rotor cannot spin because it will create two forces. So the rotor stuck. So we need to implement the auxiliary winding circuit. This will eliminate one of the field, but it will masuk ke dalam one of this field. So it will enlarge this field. So basically, this EF is much higher compared to dengan EP. So this will make the rotor turn in unidirectional point. So we have SF and SB. So the equation for SF is equal to S and SB is equal to 2 minus S. And this is the equivalent circuit for individual forward and backward. And then in order to combine the stator and the rotor punya equivalent circuit, you have this equivalent circuit. So in order to calculate I1, you need to find your punya ZT, and you need to make this one into single resistance. So you can calculate I2B also using current divider rule, and you can calculate about the power air gap forward and backward. And you also can calculate the power developed, the forward torque, backward torque, and the torque developed. So do you have any question for this one, the single phase induction motor? Okay, so we will continue next class on the classification of a single phase motor, where we will look what are the types of starting for the single phase induction motor. Okay, so if you do not have any question, we continue on Wednesday, and we will do a revision on Wednesday for your upcoming fest test on Monday. Okay, that's it. Thank you. Assalamualaikum.
Thank you.
Thank you, sir.
Waalaikumsalam, sir.
Thank you, sir.
Salam. Thank you, sir.
Sir.
Okay, thank you, Mohammed. Okay,
Okay, thank you, sir.
thank you, bye. Assalamualaikum.